All right, so let's finish up number 6 here. So we got our answers for number 6. We did get 6 answers for number 6 part A. That was because we were kind of equal to 3 different numbers. Usually on these ones, we've talked about every number that you're equal to usually gives you 2 answers. So 0 gave us the answer of 0 and pi. Positive 1 over rad 3 gave us pi over 6 and 7 pi over 6, and then negative 1 over rad 3 for tan gave us 5 pi over 6 and 11 pi over 6, okay? So for part B, we're having to write the formulas for these. And remember, it's different writing the formulas based on whether or not they are diameter buddies or not, okay? So we need to see, do we have any diameter buddies here? I'm actually going to say that these are all diameter buddies. So diameter buddy means you can connect them with a line, a straight line that goes right through the middle of the circle. And so you can see 0 and pi are diameter buddies. We also see that pi over 6 is diameter buddies with 7 pi over 6. And we see that 5 pi over 6 is diameter buddies with 11 pi over 6. So when we're writing our formulas for diameter buddies, we group them together like that. And we only write one formula per pair. So we are going to be writing 3 formulas here, one for each pair of diameter buddies, okay? So I'll set up my 3 formulas here. I'm actually going to do the first one last. So let's start off with pi over 6 then. So I'm going to do pi over 6. And then when we're doing these diameter buddies, we always add pi k. If they're not diameter buddies, we add 2 pi k. We'll get to that on the next question. I'll tell you we do not have diameter buddies. So this one is pi over 6 plus pi k. So that takes care of pi over 6 and its diameter buddy, 7 pi over 6. Then I'm going to do 5 pi over 6 plus pi k. And that takes care of 5 pi over 6 plus its diameter buddy, 11 pi over 6. And so lastly, I'm going to do the first one. So this one would be 0 plus pi k, except I'm actually just going to write pi k. It really is the same as 0 plus pi k. If you wrote 0 plus pi k on a paper and I was grading it, I would mark that correct. I'm not sure what WebAssign would do with that, but I think you can see that the 0 is unnecessary to add out front, right? Because the 0 is literally means nothing. That's actually something my son, must have taught my son at preschool, because he came home one day and now he says it all the time. He's like, Dad, 0 is a number that means nothing. And I shed a tear and I was like, that's my son. I love you so much. Yes, that's an important math fact to know. Okay. And I'm really impressed that at 3 years old, he's figured out that 0 is a number that means nothing, because it's kind of an abstract concept. And I'm very proud of him about that. All right. Yeah, he's 3 years old. He can count up to 29. It's pretty impressive if you ask me. He definitely could count from 0 to 10 before he knew any letters, which I said, good job, son. Those letters, not important. Don't need to read and write in this life. Just need to know your numbers, okay? No, that's just, I'm kidding. I didn't really say that. I just thought it. Okay, no, just kidding. Not really. Okay, so we're all done then with part B here. We got our 3 formulas, all right? Fun stuff. All right, so I'm going to clean off my unit circle here, and then we'll move over and do number 5 now. Number 5 is a tricky one for sure, but I'm sure we can do it, considering I've already done it 2 times today. All right, I'm going to move my unit circle like way down here because we're not going to need it for a while because we got a lot of work to do, okay? All right, so this one here, let me grab a different color. We see we have like a cosine squared and a 7 cosine, right? A negative 7 cosine. So some people may be thinking about GCF a cosine there, but we actually don't want to do that. The reason why is we don't want to factor when we're equal to -3. We only want to factor when we're equal to 0. So the first thing I need to do is add this 3 over to this side. Now, obviously, that does not have a like term on the left-hand side. So I'm just going to tack it on back. So we can no longer GCF because now that 3 is over there and the 3 doesn't have a cosine that we can pull out front, right? So what type of factoring are we going to do? Well, we're actually going to do one of these guys. Remember that? A times C on top and B on bottom. It's been a while, hasn't it? It's a good thing to go over though. But to make this a little bit easier as well, I'm actually going to use something else that we've used before. It's been a while as well. I'm actually going to use a little U substitution here. Remember we used to do U substitution? So remember U substitution you sometimes do on these like complicated quadratics, and it makes it just a little bit easier to visualize it. It's actually not necessary, and I'll show you how you can do this as we go through without the U substitution, but I'm gonna go ahead and use it. I'm gonna go ahead and use it, get it? So I'm gonna let U equal whatever my trig function is on these ones. So in this case, I'll let it equal cosine x. I think there's a problem later on today where we will make it equal sine x. That's okay. Remember, it's kind of just made up arbitrary thing anyway, right? So if I let u equal cosine x, then we can rewrite this as 2u squared, right? Since it was cosine squared, I would just write it as u squared minus 7u plus 3. And when you look at it like that, I feel like it makes it a little bit more approachable when it comes to the factoring, correct? All right, so let's go to the x now. And so a times c is 6 and b is -7. So we have to think of two numbers that multiply to 6 and add to -7. So in my mind, that would have to be -6 and -1, correct? Okay, so then we use those numbers here to split up the middle term. So this would be -6u minus 1u. And then the first and the last term you just bring down and you split up that middle term. Quick note here, if you didn't use u substitution, you could actually still do this x here, and it'll be -6, -1, and you just split up this middle term. It would be like -6 cosine x and -1 cosine x. It would actually still work. It just, to me, it's a little bit, looks intimidating. Okay, so that's why I like using the u substitution. All right, so now we do factor by grouping here after we split up that middle term. So now we have 4 terms, we can do grouping. The first group, I can pull out 2u, leaves me with u minus 3. The second group, I got to take out a -1, which flips the sign here, which makes it u minus 3. Good news there that I got the u minus 3, the same thing in both parentheses, right? That means I probably did this correctly. All right, so now I can write this as 2u minus 1, u minus 3. Great. So I'm actually all done factoring here, but I'm actually far from being done with the problem. Because remember, this problem had nothing to do with u, right? This problem was all about cosine x. I just made up u to make it easier to factor. So once I'm done factoring, I'm done with u. I'm going to plug the cosine x back in for u, okay? So now I just need to solve that. Good news about that is it's factored equal to 0, which is in a good spot. Because what I'm allowed to do with that is split up my factors, set them equal to 0 individually, and solve. All right, so I get 2 cosine x minus 1 equals 0, and cosine x minus 3 equals 0. So I'll isolate the cosine on both of those. So the first one, I add the 1, divide by 2, so I get cosine x equals 1/2. The next one, I just add the 3, so I get cosine x equals 3. All right, so now I am finally ready to look at the unit circle, and we'll answer part A first. So between 0 and 2 pi on our first trip around the unit circle, where does cosine x equal 1/2? Or in other words, where is the x value on the unit circle? Points 1/2. I see 2 points where the cosine is 1/2. I would say that it is at pi over 3. We have the x value of 1/2, right? Y también 5 pi over 3. We have the x value of 1/2, okay? One thing I forgot to mention yesterday that I'll bring up today, when you're thinking about finding positive versus negative stuff, remember the all students take calculus trick, right? Where we said that like everything's positive in quadrant 1, sine is positive in quadrant 2, etc. So if we're looking for a positive cosine, it makes sense we'd be looking in quadrants 1 and 4, correct? Because that's the all and the cosine quadrant. If I was looking for a negative cosine, I would be in 2 and 3, right? Because that's the sine and the tan quadrant. Okay, next up, where does cosine x equal 3? So where is the x value of 3 on the unit circle? Never. Cosine x never equals 3. Why not? Well, if you look at this spot right here on the far right of the unit circle, that's actually the biggest that cosine ever gets, and it's 1. This on the far left is the smallest cosine ever gets, and it's -1. So cosine x is always in between -1 and 1. So if you get something outside of that, it's impossible, okay? You can also kind of think about it. Remember when we were graphing cosine x, the graph went up to 1 and down to -1, right? And in between those, back and forth. So just think about that graph, right? It's always in between -1 and 1. Sine is the same way, right? Think about the sine graph. It's the same thing between -1 and 1. All right, so sine and cosine always must equal something in between -1 and 1. However, I'm going to say that these two, I'm just going to box up those two answers. Because remember that we're solving this way big equation back up here, right? Like this is our goal, is to solve this equation. Now we did break that up into 2 smaller equations. And so even if this one doesn't give you any answers, just focus on the part that did give you answers. I've had people answer this question before on like a writing test and say x equals pi over 3, 5 pi over 3, and no solution. And I'm like, how are you going to tell me there's no solution when you literally just told me 2 solutions, right? So yeah, if you get one piece that doesn't give you answers, don't worry about it. Just focus on the one that does give you answers, okay? All right, so now let's go over to part B. So part B, we write our formulas. The formulas are written differently based on whether these are diameter buddies or not. Are these 2 diameter buddies? I'm going to say no. If we connect these 2 with a straight line, that line does not go through the center of the circle, the exact center of the circle. Therefore, these are not diameter buddies, right? And if they're not diameter buddies, that means I do not combine them with the formulas. I write them separately, and each one of them plus 2 pi k. So there's my answer for part B. Each one of my solutions from part A, since they're not diameter buddies, plus 2 pi k. All right. All right, let's move along to the next question here. I'm going to bring my unit circle along with me, hopefully. There we go. And we'll tackle number 7 here. This is a good one. I like this one. It's not too hard. All right, so this one we have like different trig functions. We got some tans and some cosines, right? What we're gonna want to do on these ones is get one side to 0, okay? And I'm gonna add something to this note. I'm gonna say by adding or subtracting. So a lot of people on this one, they divide the cosine over to the other side. You don't want to do that, okay? If you divide both sides by cosine, you'll actually end up with some correct answers, but you'll also end up missing some answers. So your answer won't be wrong, it'll just be incomplete. So instead of dividing the cosine over, we are going to subtract the cosine over. Now, that is not a like term here, so I cannot cancel out the cosines. I have to just, put it out back with a minus. It's like if we had xy minus x, I can't cancel out the x's. But what we can do is factor, okay? And factoring on this one, since nothing is squared, but we have two terms, factoring means GCF. All right, so some people say F it, I say GCF it. How about that? So what's the common factor between these two terms? Well, I think it's pretty clear, it's cosine x, right? So if I take out cosine x, it leaves me with tan x minus 1. Remember, GCF is the kind of the opposite of distributive property. So I always like to check my work when I GCF by doing a quick distributive property in my head. So watch this. Cosine x times tan x gives me tan x cosine x. Cosine x times -1 gives me the negative cosine x. So verification complete. All right, so now I'm ready to split these up, set them equal to 0 individually and solve. So cosine x equals 0, it's already solved. Tan x equals 1. I solved from tan x minus 1 equals 0, okay? So now we've isolated our trig functions, and as you can see, I'm setting up my unit circle because I'm about ready to go to the unit circle and answer part A here. I think again here, I'm going to get 4 answers. I'm going to get 2 answers for each of those, 2 answers for cosine x equals 0 and 2 answers for tan x equals 1. All right. So where does cosine x equals 0? I would say right here at pi over 2, we have an x value of 0, right? So that's looking good to me. And then down here at 3 pi over 2, we have an x value of 0 as well. So there we go. All right, and then where does tan x equal 1? This one's a little tricky. We haven't seen tan x equal 1 yet today, or in this section. I'm gonna go ahead and tell you the answer now, which may surprise some of you, but when I explain it, it will make sense. So where does tan x equal 0? Well, the first spot is actually pi over 4. Why is it pi over 4? Well, remember, tan is y over x, correct? So look at the coordinates of pi over 4. Rad 2 over 2 over rad 2 over 2. It's just the same thing divided by itself, right? A divided by A, that's 1, right? So pi over 4 will give us a tangent of 1. If you're thinking it was 0, it's not. Remember, tangent of 0 is 0 over 1, which is 0. Tangent of pi over 2 is 1 over 0, which is actually undefined. It's not 1. It's undefined. All right, so where else does tan equal 1? Well, remember I said that tangent, always the answers come in diameter buddies. So I can actually safely assume that 5 pi over 4 is also a solution. But if you actually look at 5 pi over 4, it still is, if you do the y over x here, it would be negative rad 2 over 2 over negative rad 2 over 2. So now it's like negative a over negative a, which is still a positive 1, correct? We also remember that the third quadrant's the tan quadrant, so tan is still positive in third quadrant. So if your tan x equals negative 1, that's going to be the other 2 pi over 4s. That's going to be 3 pi over 4 and 5 pi, or sorry, and 7 pi over 4. That'll be the negative ones. So there's my 4 answers for part A. Now let's move on to part B. All right, are any of those answers diameter buddies? The answer is actually yes, they both are. Pi over 2 is diameter buddies with 3 pi over 2. You can see I can connect them with a straight line that goes in the middle of the circle. And then pi over 4 is diameter buddies with 5 pi over 4. I'm not surprised about pi over 4 and 5 pi over 4 because they came from a tangent, right? And I said tangent always creates diameter buddies. We're a little surprised about these two being diameter buddies because they came from cosine, but I did say cosine sometimes creates diameter buddies, right? So it's not like crazy. It does happen, okay? And this is one of those cases. So since both of these are diameter buddies, I'm going to take each set and write the first one plus pi k. And so pi over 2 plus pi k takes care of pi over 2 and its diameter buddy 3 pi over 2. Pi over 4 plus pi k takes care of pi over 4 and its diameter buddy 5 pi over 4. Holla, good job. There we go. All right, now we'll go on to number 8. I think number 8 will be the most difficult question we do today, so that's exciting. We'll feel very smart after we finish it, though. How about that? So I'll go ahead and move my unit circle down here. All right, so this one is a little bit like number 5. So number 5, if you recall back up here, we started the day with that. We had like a cosine squared and a regular cosine and a number. So we had to do the like X diamond thing. So this one is kind of like that, except the problem is my squared thing is a cosine and my non-squared thing is a sine. So I'm never going to be able to factor a cosine squared with a regular sine. So I have to either turn everything into sine or I have to turn everything into cosine, all right? Is that possible? Well, let's remember back to last section, and we actually learned a way to turn a cosine squared into something to do with sine squared. What did we turn cosine squared into in our last section? I can't remember. It's right at the tip of my tongue. Oh yeah, now I remember. It was 1 minus sine squared x, right? You guys remember doing that in our last section? We turned cosine squared into 1 minus sine squared. Good, so I would only do this, like I said, it's like on an equation like this where I have a sine and a cosine squared. Or if I had a sine squared and a regular cosine, I would switch the sine squared. You can only switch the squared one using that Pythagorean identity, okay? All right, so I'm gonna go ahead and distribute this 2 then. Okay, so now we have a squared and a regular sine. So that means we need to get everything to one side, have one side at 0, and then we need to factor, okay? Now, whenever I'm doing that, I always like my squared thing to be positive. So for that reason, I'm gonna move everything, as Beyonce would say, to the left, all your terms in standard form to the left. You must not know about factoring, you must not know about factoring. That's based on a song by Beyonce that was super popular when Mr. Barry was in high school. when Mr. Barry was in high school, Beyonce was one of the most popular musicians in the world. Now I'm an old man, and let me check. Beyonce is still one of the most popular musicians in the world. How is that even? How is that possible? Like, I'm old. She might have been popular when I was in middle school, and she's still popular. What? How? What? Okay, let's move on. So we got 2 sine squared x here. 1 minus 2 is -1, but I'm going to put that back there. And then I have that plus sine x in the middle there. Yeah, she was in Destiny's Child when I was in middle school. So like popular, but part of a group. Then she broke off and became more popular. All right, so now we're gonna do our x factoring, but before we do, I'm gonna go ahead and use the u substitution again to make it a little bit easier. We'll let u equal sine x. All right, a times c is -2 and b is 1. So 2 numbers that multiply to -2 and add to 1 would be 2 and -1. So split up the middle term there. And I split up the middle term according to these numbers that came from the x. All right, now grouping. All right, good news. I got the same thing in both parentheses. So that gives me 2u minus 1 times u plus 1. All right. But let's remember, we weren't talking about u, we were talking about sine. So this is really 2 sine x minus 1 times sine x plus 1 equals 0. So now we can split that up, set them equal to 0 individually, and solve. All right, so I got sine x equals 1/2. I got sine x equals -1. Ahora estamos listos para ir al unit circle. In English, now we're ready to go to the unit circle. All right, so where does sine of x equal 1/2? Let's check that out. So I see that right here at pi over 6, correct? We usually expect 2 answers from this. So does sine x equal 1/2 anywhere else? Yes, it does. Right here at 5 pi over 6 as well. All right, so now where does sine x equal -1? For this one, this is a rare instance where it actually only equals -1 at one spot. You guys see it? All right. There it is. 3 pi over 2. So yeah, when sine and cosine equal either 1 or -1, that's only going to give you one solution, all right? Those are it's rare. Those are the rare instances when that happens, all right? So I actually got 3 answers for part A. Are any of those answers diameter buddies? The answer is no. I cannot connect any one of these 3 answers using a straight line that goes through the middle of the circle, right? The exact center of the circle. No, no, no. It's like a triangle, right? All right, Illuminati confirmed, first of all. Second of all, let's write our answer for part B. So since we have no diameter buddies, we're just going to list all 3 answers plus 2 pi k, right? All right, so pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k, and 3 pi over 2 plus 2 pi k. Awesome. All right. Man, let's zoom out a little bit and look at all the work we did. Look at that. Gosh. I don't know. I always feel accomplished looking at all that. Like, I feel like, wow, I'm a genius. All right. Like I said, this is definitely the hardest problem we'll have in our notes. And so we may have one question this hard on the test, but most of them will be easier than this, remember, okay? All right, so let's go down to 9 and 10. These ones are a little different, but I would not say that they're harder. So this one's called multiple angles. And so what I mean by that is like when you got something weird inside the sine, cosine, or tangent, like 2x, 3x inside, or even x over 2, like we see on number 10, or x over 3 or something like that. So for these ones, the first several steps are the same as they were before. The 2x inside you actually deal with, that's the last thing you deal with, okay? So let me show you. So we're going to isolate the sign. So I'm going to, just like I would have before, I'm going to add the 1 over. I'm going to divide the 2 over. The 2 that was in front. I'm not going to divide the 2 that's inside. My next thing I'm going to do is I'm going to look at the unit circle, okay? So let me grab my unit circle, bring it down here. All right, so, for these ones too, we're going to do part B only, okay? We're actually not even going to do part A. Part A on these ones is actually super difficult, and so we're going to skip it. Let's just do part B, okay? And I'll tell you, the part B, and I think I mentioned this yesterday, on most of the questions, not just this type, on all of these questions, the part B is mostly what WebAssign is going to be asking you, okay? All right, so where does the sine equal 1/2, right? Well, we just did that on the previous question, and we determined it was pi over 6 and 5 pi over 6, correct? That's just kind of, yeah, you can look at the unit circle or reduce it on the previous question. So those are not diameter buddies, right? And so if I was writing the formulas for those, I would do each one individually plus 2 pi k. So I'm going to do that here. Notice I've left the front blank, and I've also left some space in between these. That was intentional. So why did I leave the front blank? Okay, because normally if this said sine x equals 1/2, I would have just said x equals those 2 formulas and been done, right? But now that it equals 2x, I'm setting those equal to 2x instead of equal to x. And so this is now, I'm not done yet. I have one more step on each of those formulas, which is to get rid of the 2, okay? And so I get rid of that 2 after I look at the unit circle as my last step. So I could divide both sides by 2, I'm going to tell you what's a little bit easier here, and it means the same thing. I'm going to multiply both sides by 1/2. And I just do that because we have some fractions in there, correct? So it's kind of easier to do it dividing by 1 or multiplying by 1/2 than dividing by 2, even though they mean the same thing. So 2x times 1/2 is just x. Pi over 6 times 1/2 is pi over 12. 2 pi k plus 1/2 is just pi k. So my first formula is going to be pi over 12 plus pi k. Now, even though it's plus pi k, these are still not diameter buddies, all right? The pi k just kind of came up because of the dividing by 2 or multiplying by 1/2 is my last step. All right, so same thing here, multiply by 1/2. So that gives me 5 pi over 12 plus pi k. So that's it. Not too bad, right? So like, yeah, on these ones, like at this step, your formula is going to look pretty normal. And then when you get rid of it, sometimes it does look pretty weird here, right? An answer like we don't really see on any of the other questions. All right, so let's do the last one then real quick. I think we can get it done. All right, so this one, I would just add the 1 over. I would divide the rad 3 over. All right, so where does tan of x, where does tan equal 1 over rad 3? Well, it's actually at pi over 6 here. And you can kind of visualize that with the y over x, the 1/2 over rad 3 over 2. That would put the radical 3 on the bottom because I'm doing y divided by x. And then we know for tan that its diameter buddy would also be an answer. So those are my only 2 answers. So since they're diameter buddies, when I'm setting up my formula, I just have to do one formula, which is the first one plus pi k, right? But now, instead of equaling it to x, I equal it to x over 2. All right, so now I need to isolate x by multiplying both sides by 2 over 1. And that tells me that x equals 2 over 1 times pi over 6. I would cross cancel the 2 and the 6. It would leave me with pi over 3. And then 2 times pi k would be 2 pi k. So this one, even though it's plus 2 pi k, they still are diameter buddies. It's just that multiplying by 2 made it a 2 pi k. Okay? Oh my gosh, that was your last notes you'll ever do in pre-calculus class, hopefully. All right? Not for me, though. I got to do it one more time today, and then 4 more times a day for the next 28 years or so. Awesome. Or until a robot takes my job. Okay, cool. All right. 7.5 WebAssign has been posted. It's due next Wednesday, but I would encourage you to work on it over the weekend because our test is next Thursday, and we'll have some other review materials to work on next week as well. So you don't have to finish 7.5 this weekend, but I would say use your notes to get started on it, see what you know, okay? All right, we are out of time, so have a good weekend, and we will see you on Monday. Bye. All right.